This is the year 2043. All governments have fallen. Banks do not exist anymore. In this world of chaos, you set up some money for your kids and you want to give it to them when they are adult. Your mission, if you choose to accept it, is to build a trust fund for your kids. For that, you will code a smart contract on the Ethereum blockchain. It's not gonna be easy, and if you fail, your kids will die poor and alone. But fortunately, you'll find this video and I'm going to guide you to code our smart contract. If you don't know me, I'm Julian, and on Eat the Blocks, I explain blockchain technology. For our smart contract, we will use the Ethereum blockchain. There are many other blockchains, but Ethereum is the most active. Ethereum is a network of computers. Each computer runs what we call an Ethereum node, a fancy name that just means the software of Ethereum. On Ethereum, like on Bitcoin, you can do financial transfers using the native cryptocurrencies of Ethereum, Ether. But what makes Ethereum so powerful is smart contracts. Smart contracts are little programs that run on the blockchain. These programs are unstoppable. Once you deploy them, they run forever, nobody can stop them. It's also not possible to modify their code. Smart contracts are written with a programming language called Solidity. The syntax is similar to JavaScript, but under the hood it works very differently. Next, we are going to start coding our smart contract. This is how the smart contract is going to work. So the parents will deploy the smart contract, send some Ether. This Ether will be locked until the kids are adult, and after, kids will be able to withdraw the Ether. To code our smart contract, we are going to use a tool called Remix. That's a code editor for Solidity. You just have to go to the address in your browser, nothing to install, super easy to get started. First, we will go to this menu here and make sure that we are using Solidity 0.8.1. That's the latest version currently. Make sure you enable auto-compile here. Okay, so then we're going to go to the File Explorer and create a new file. We're going to call this trust.sol. So it opens up the file automatically, and that's where we will write our Solidity code. So when you start the smart contract, the first thing is to start with the pragma statement. So you need to specify which version of Solidity you are going to use. So in our case, 0.8.1, and you terminate your statement with a semicolon. Then you start your smart contract with the contract keyword, then the name of the smart contract, that you open curly braces, and everything inside is the code of your contract. Then we're going to declare a couple of variables, so these are stored in the blockchain. So first, we're going to declare the address of the kid. So on Ethereum, if you want to send and receive Ether, you need an address. Anybody can create an address by using a wallet software. It's totally free. So each kid will have his own wallet and his own address. Then we're going to create another kind of variable of type integer. And the public keyword means that we can read this variable from outside the smart contract. This is going to be the maturity. This is the date when the kid will be able to unlock the Ether. But why do we store a date into an integer variable? So in general, for computers, the way we deal with date is by using timestamp. So timestamp is the number of seconds since 1st of January 1970 UTC. For example, if you want to know the current timestamp, you can go to this website, unique timestamp, and gives you the timestamp here, and so it keeps going up. And so it's how we represent dates in computer, and in smart contract is the same thing. So here we have defined our variable, but then we need to define some rules for how to manipulate these variables. And for that, you need functions. And there is a function which is a little bit special called the constructor. The constructor function is only called when you first deploy the smart contract. So if you have any initialization logic, that's where you're going to put it. So you declare a constructor with the constructor keyword, and you can pass some variable to the constructor. So first, we are going to pass the address of the kid, and then the time to maturity. So for example, Can be 10 years, 20 years, etc., but expressed in second. And then we're going to add the keyword payable. So that means we can send some Ether when we deploy the smart contract. So the smart contract itself is able to have a balance of Ether. And after, we are going to initialize the value for maturity. So it's going to be the current timestamp. Here we have a special variable in Solidity block.timestamp. And we're going to add time to maturity. So this maturity thing is going to be a timestamp in the future. And we're also going to initialize the kid variable. So this address here, this is going to be underscore kid, what we got as an argument. And after, we need to create a function to allow the kid to withdraw the money. Withdraw. So we don't have to give argument to a function in Solidity. So this function doesn't have any argument. Then we're going to add the external keywords. That means this function can be called from outside the smart contract. You have different visibility keywords in Solidity, and you can also define some functions that are internal, so just callable from the smart contract. And before we send the money to the kid, we are going to do a few checks. So you can do this with a require statement. It's going to test a condition, and if the condition is satisfied, it's going to continue the execution. Otherwise, it's going to throw an error and stop the execution. So we need to make sure that we are after the maturity. So for that, the current timestamp needs to be superior or equal to the maturity variable. And we can also put an error message, so too early. Okay, and after that, we also going to make sure that the address that is calling this function is the kid. So there is another special variable in Solidity, msg.sender. And here it's how you can make a comparison. I want the sender to be the address of the kid. And after that, an error message. If this is not the case, only kid can withdraw. All right. And after, we are going to send the money to the kid. So for this, you can use msgsender.transfer, and we are going to transfer all the money that is in the smart contract. So address this dot balance. That's how you get the Ether balance of the contract. So just to be clear, this line here means we are going to transfer this amount of Ether to this address. And in Solidity 0.8, there was a change for MSG sender. So to be able to send money to MSG sender, we need to transform it into address payable. So we do this that way. So in Solidity, you have two kinds of address and address payable. We can only send Ether to the address payable. Okay, so our contract is working, but it's a bit limited because it only works for one kid. But maybe that we want to have several kids, so we need to modify the logic a little bit. So for that, we are going to remove this variable, and instead we're going to use mapping. So mapping in Solidity, they are like key value store. So we can associate some data to specific key. For example, it can be the balance of different addresses. For example, address 1, 0x, etc. can be associated to this balance, this other balance, this other address can be associated to another balance, etc. They are like objects in JavaScript. So first, we're going to have a mapping of address to integer. Make it public so we can read this from outside the smart contract, and we call this amounts. So these are the amounts that we give to the different kid. And then we're gonna have another mapping for maturities, because kids will become adult at a different time. Maybe one kid's gonna be 15 years, another kid in 10 years, etc. So we also make it public. We call this maturities. And this time we will not have a constructor, but instead we're going to have a function to add a new kid after the deployment. So we're going to specify the address of the kid, and then what's the time to maturity, and this is going to be external plus payable because we're also going to send Ether to this function, and we're going to update the two mapping. So first amounts kid, this is going to be the amount of Ether that we send to this function, so we can get this value with MSG value here. You don't have to send Ether when you call a function, but in our case we're going to do it. Then we're going to update the maturities mapping, so that's when the kid can withdraw the Ether. So this is the current timestamp plus the time to maturity that we pass as argument. Then we need to modify the withdraw function. So we are going to require that we're after the maturity for the kid. So for this, we're going to check with the mapping maturities of the kid. Okay, so we're going to pass this as an argument, address kid. This needs to be inferior to the current timestamp, and the error message is too early. And we also need to make sure that only the kid is able to withdraw money, otherwise everybody can steal our money. So for that, we're going to check with the amounts mapping, and this needs to be superior to 0, otherwise we're going to display only kid can withdraw. If you pass an address here that is not the kid, when you try to access an entry for the amounts mapping, in Solidity, you can still access an entry here, even if it doesn't exist. So in this case, since this record doesn't exist, it will map to the default value of integer, which is 0. So if we found that 0 is associated to an address, it means that this is not a kid. So this is how we can make sure that this is the correct address for the kid. And after, we are going to pay to the kid the balance, no, not all the balance of the contract, but only the amount for the kid. So it's amounts of kid. Okay, actually I don't really like the way we created the withdraw function, because here we pass the address of the kid as an argument, but we could make this a little bit more simple and more secure by instead here we are going to use MSG sender. So that's the sender of the transaction that call this function, and there is no way to hack this. If you call the withdraw function from a certain address, MSG sender will always be equal to this address. This is guaranteed by the Ethereum protocol. So here we're going to do the same thing, msg.sender, and here same payable MSG sender, and same thing here. Okay, this is better. It's possible for a kid to call this function several times and to basically steal the Ether from the other kid. So in order to prevent this, we are going to create another mapping, which is going to map addresses to Boolean value, so true or false, and it's going to record who has been paid or not. So when you add a kid, you don't need to initialize the entry for the paid mapping, because by default this is going to be equal to false. And in a withdraw function, we are going to add a condition, which is require paid MSG sender to be false, and otherwise the error message is paid already. Don't try to steal from your brother and sister. All right, and we're also going to update the paid mapping with paid MSG sender equal true. Oops. Okay. Then we're going to add some security to the add kid function, because currently anybody can add a kid by calling this function, but we want to restrict this ability only to the parents. So for that, we are going to define an admin address, which is going to be the parents basically, and we're going to create a constructor that's called only when the smart contract is first deployed, and we are going to initialize the admin to the address that deployed the smart contract, so that's the parent. And in the add kid function, we are going to require that the sender of this transaction is the admin, so only admin. And we're also going to make sure that we haven't already added the kid. So for that, we're going to use same technique we use here. We're going to check if the value of amount is 0 or not. And this time we require that it doesn't exist. And the error message is kid already exists. Okay, so we are almost good with the smart contract, but the last thing we're going to do is some gas optimization. Every time we call one of these functions here, add kid or withdraw, we are sending a transaction to the Ethereum network and we need to pay for transaction fees. We use a unit called gas, and gas is a topic in itself. If you're curious about it, I have a whole series on gas on my channel. But the point is that we need to make sure that our Solidity code is the most simple possible so that the gas cost for using our smart contract is as low as possible. But here we are using all of this mapping, and maybe we could do something a little bit more efficient. So for that, we're going to introduce another concept of Solidity called a struct. It's like an object, basically, like a wrapper, and you can put some data in it. So first, we're going to have the amount, then the maturity of a kid, and then a Boolean value to say if the kid was paid or not. And then we can have a mapping of addresses that maps to kid. And we're going to call this kids. Okay. So we remove this. And after, we're going to update our code. So here it's going to be kids of MSG sender dot amount. That's how you access the field of a struct. And after, we are going to create a new kids entry like this. So kid, and here we use kid with an uppercase K. So that means we refer to the struct here. And the first argument is the amount of ether for this kid. So that's what we send in a transaction. Then the maturity, so block.timestamp plus time to maturity. And after, was the kid paid already? At the beginning, it's false, of course. Okay, let's get more space here. And we can get rid of this. Okay, so next we need to update the withdraw function. So first we're going to define a pointer to our kid. So you can do it that way. First you define the type of the variable, then the memory location. So here, storage, that means we refer to what is stored in the blockchain. Then kid with a lowercase k, so that's the name of the variable. Here this is the type, and here this is the name of the variable. And here in our kids mapping, we are going to reference the correct address. And here this is going to be kid dot maturity, which is inferior or equal to block timestamp. Then it's going to be kid dot amount, and then kid paid. And then here kid dot paid, we're going to update this to true. And for the amount, this is going to be kid dot amount. Alright, we are done with the coding. This is the final obstacle. Everything we've done so far will be for nothing if we fail here. Once we deploy a smart contract, it's impossible to change its code. If there are bugs in our contract, our kids might never be able to get the money, or the money might be stolen. So we do need to test our smart contract. For testing our contract, we will deploy it on the Ethereum blockchain and interact with it. If you deploy a smart contract to the real Ethereum blockchain, it costs money and you can break things. It's not really ideal for development. Fortunately, we can use a safe sandbox totally isolated from the real Ethereum blockchain. That's what we call a local development blockchain, and Remix provides one. We go to this menu here, deployment, and we're going to go through the main parameters. So first, the environment. JavaScript VM, it means the local development blockchain. Then here the account for deploying the smart contract. So by default, for the local development blockchain, Remix generates all of these addresses pre-funded with some Ether. So here we are talking of a fake Ether, only valid on our local development blockchain. So of course, you cannot spend this Ether on the real blockchain. Otherwise, that would be too easy. So we select the first one. Gas limit, this is to control the maximum transaction fees, but I'm not going to talk too much about gas in this video. Value, this is for if you want to transfer Ether in your transaction. After you select which contract you want to deploy, and you click on deploy, and if you scroll down here, you can expand this and you see your smart contract. Now it's deployed on the blockchain. And so for each of your function, you can see some buttons here like add kid or withdraw. So we are going to add a kid, and after we're going to try to withdraw. So we need to provide the argument for add kid. So the kid will be the second address. So here, let's copy this, scroll down, add kid, this is the address. Then for the time to maturity, we're gonna pick 30 seconds. Then let's scroll up, we select the first account, that's the admin. Then for the value, we're gonna choose 1 Ether. All right, so now we're gonna execute add kit. So we click here, and here you can see that we have a green check mark. So that means the transaction was successful. So now let's switch to the address of the kid and we try to withdraw. And here VM error, the transaction has been reverted. Reason provided, too early. So this is too early because we need to wait 30 seconds. If we try again, I think this is still too early. Yes, so everything is working as it should. Also, if we try to withdraw from another address, it should also fail. Withdraw. Okay, so now we have another address, only kid can withdraw. So this is working as intended. So let's go back with the address of the kid. Now we withdraw and the transaction works. And now let's make sure that the Ether was actually transferred. So we can see that 1 Ether was taken from the first address and 1 Ether was sent to the second. So it's not the whole number because we have to use a tiny fraction of this Ether to pay for transaction fees. Yes, we made it! We fulfilled our mission, which was to build a trust fund to donate money for kids in the future. Now you know how to code a smart contract on the Ethereum blockchain using the Solidity programming language. If you keep working on your blockchain skills, one day you will be good enough to become a professional blockchain developer. As a blockchain developer, you can work on interesting projects, you usually can work remotely, and you can make $100,000 a year, not bad. Next, you can continue your blockchain journey by learning how Ethereum works, and you can also dive deeper into Solidity to make more advanced smart contracts. I'll see you there.